So, sorry for whoever's trying to watch this, but we forgot to record because we were all trying to find our test, but we'll start recording now. So number 5, this is on B, but it sounds like everybody's saying it's both A and B version. So what is the component form of the vector that maps ABC to A prime, B prime, C prime? A couple things going on here. Okay, break it apart. Don't get lost in the language. What is the component form? Okay, pretend like you don't know what component form is, and let's think about a vector. What's a vector? I don't remember what a vector is, Mrs. Muller. Well, let's see if we can figure anything else out. ABC to A prime, B prime, C prime. ABC to A prime, B prime, C prime. So mapping from one to another, right? Isn't there like a connection between them, between the vertices? Correct? You remember? From A to A, okay, so if I want to find how A, B, and C map to B prime, C prime, and A prime, all I have to do is measure this vector. You can even take and draw the vector over here. It doesn't matter what the vector is because I just have to count. Yes, it is. What? 1, 2, 3, over 4, and down 2. Over 4, down 2. How do I finish this up? Is it like this? What is this? This is a point on the graph or an ordered pair. That's this. 4, negative 2. That's not correct. You have to do, yes, just like that.
Oh my god, I did it right. All I did was I put 5, negative 2 by accident because I miscounted one and I did it. And then I even put a little 1.
That's what I needed.
Wow.
Okay? You did it in the wrong order. Well, now you won't do that again now that you know what you did wrong, right? Okay, guys, let's keep going. Let's do number 6 and 7 on B, and then I'll switch over to A. Are these the same on both versions?
The 6 is, yes, 6.
They are? Perfect. So this is A and B. All right, so this says draw the image of triangle ABC along, what do I call this guy, this V? That's vector V. Here's vector V. Hold on. So how do I use vector V? Guys, how do I use vector V? That wasn't a very good vector. What? It's exactly what we just did. You have to take each one of your vertices and map it down that vector. This is where patty paper could come in useful. So I need to go over 1, 2, 3, 4, 5, and down 2. What would this component form be? No. No, component form of this vector. 5, negative 5, negative 2. Good, Michael. Right? I'm going back 5 and down 2. So I'm going to go back 5 and down 2 for all of my vertices. 1, 2, 3, 4, 5, down 2. There's B prime. 1, 2, 3, 4, 5, down 2. There's C prime. Right? Better? Did you catch your mistake?
Yeah.
Does it look the same? Mapped over? Good, let's do this one.
tying together on that.
Good. All right. You could measure this slope and do the opposite, because perpendicular lines have opposite slopes. So if my slope is 1/2, what would perpendicular slope be? Negative, and then it's the negative reciprocal, 2/1. So see this? Right here, it's up 2/1, up 2/1, up 2/1. So what would the negative reciprocal be?
Yeah. 1/1.
1/2 and positive. See how I went up 2 and then to the left 1? Up 2 and to the left 1? But you don't have to know that. If you like slope and you like using slope, that's a good way of doing it. There's another way to do it. Let's see how we can get over this line. What did I say the slope was? The slope of this line is negative 2/1, and I said the slope of this one is, let's do that. Down 1/2, down 1/2, see that? Well, yeah, you have to get to the line. How do I get to the line? I'm going to go down 1/2. There's the middle. Now that's half as far as I need to go, right? Now I should go down 1 and over another 2. That's as far as I have to go. Because it's the same slope for each one of them, right? So once you figure one of them out, you know all of them. Let's see if it works for this one. Down 1/2. Yep. Down 1/2. There's C prime. B is going to take a little bit longer to get there, but I can use the same slope. Down 1/2, down 1/2. Now I got to do it twice again. Down 1/2, down 1/2. You must have it wrong in some way. We can look at it. You might have had one of these points off. Okay, so find your error and then don't make that mistake again. Better? If you guys still need help, you can come on Tuesday and I'll help you more individually, okay? Okay, we'll go over whatever Wednesday. We have a quiz on Wednesday. All right. Let's keep going. Do we want to switch over to the other one now?
Yeah.
Fine, I guess. All right. All right.
I know what I did wrong.
Good. That's what I want to hear.
Because I forgot to put the degree and counterclockwise and clockwise. But I put rotation.
Okay. Use the figure to the right. Name the specific transformation that maps ABC to A prime, B prime, C prime. All right. So this guy goes here, right? How do I get that? You got to rotate it. All right, so how much would I rotate it? Let's see. This doesn't work as well as patty paper, but we'll try it. So I've got my triangle right there. I'm going to keep that solid. I'm going to turn it for a second first here so that it's perfect. Is that going to be good enough, guys? So A, B, C, keep all that together when I turn it. All right, so I'm going to turn it see how the little turning guy, see him up here? Watch how he's at the top, and now he's on the side. See that? I went in exactly a 90-degree angle. You could see it with patty paper because you would have had this. Oh, I know what I'll do. Check this out. That's what you guys do with patty paper, right? So then, when I take it and rotate it, oh, see, it's still not going to work. It would work if I rotated this part instead. I know what I'll do. This will be the thing I'll rotate, and I'll attach this to it. I wonder if that'll work. I'm going to be so happy if this works right now. Nope. It's not going to work. Oh, well. All right, so when I turn it, see how it's 90 degrees now? And I'll just lift it. So we went 90 degrees in which direction? Counterclockwise. You could have also told me what? Clockwise. You could have told me 270 clockwise, right? Okay. So name the specific transformation. It is a rotation. What is the coordinate rule that maps it? Well, if you went 90 degrees this way, if this is x comma y, then this is negative y comma x, so it was negative y comma x. What if you went the other way, 270, what would it have been? It would have been not negative x, it would have been y negative x, exactly. If you would have went the other way, it would have been that. Yes, sir. Okay, if you have a discrepancy, we'll talk about it when I'm done.
What?
A discrepancy on your...
No, I'm saying, yeah.
You know what I mean? Like if you think you should have gotten right? Okay, because I don't want to waste everybody's time right now because we're all doing it together. But I definitely want to look at it in a minute. Okay, name the specific transformation described by the coordinate rule. What happens when I have x comma y and I go to x negative y? If this confuses you, I draw a picture. Name any point. You tell me. 1, 2. So if you applied that rule, what would this be? No. This rule right here. 1. It would be 1, negative 2, right, if you made that rule? Well, here's 1, 2, right here. And here's 1, negative 2. What happens? Well, here, we'll put a line with it. What happened when I went from here to here? Reflection over the x. Reflect over x. When you reflect over x, x stays the same and the y changes. When you reflect over y, the y stays the same and the x changes. Does that make sense? This is what I want you to start doing, guys, on your test. This is a test-taking strategy. This is probably somewhere else on your test. You know what I mean? There's like visuals in your test. So when you get stuck, go back and look at your test and see if there's any clues. You know what I mean? Go look for a, something that has this. Go get a visual and say, oh, yeah, that's a reflection. Let's see. Did we have anything yet? We have one here. There's a reflection over what? Over y. You had it right here.
Attention, students.
See what I mean?
Now at dual to y.
So you can go back and look at it and think about it. So you had an example of reflection, and you could have used it for this one. All right. Name the specific transformation described by the coordinate rule. If I have x comma y, and I add 4 to the x, what type of transformation is that? What's happening? Here, if you don't get it, make a picture. Make x, y, whatever you want. What do you want to make it?
The translation
1, 2. 1, 2. If I want to change that, here's the rule. What happens to x?
You add 4 to it.
You add 4 to it. So it would be what?
5.
5.
And then
Stays the same. So I go over 1, 2, 3, 4, 5, 2. What happened to my dot? It moved. What would we call when it just moves like that? Huh? The translation. It's sliding. Right? Sliding translation.
Where's the show word for it?
Nope.
Because I just wrote translation.
I'm just going to do 4, right? 4 points on the x-axis.
No, increases by 4 on the x-axis.
And then
That's exactly what's going on, but you needed to write if
your
it's
transformation
a translation. Okay? All right, let's switch back over to C. Alrighty. Name the angle of rotation and the direction of the rotation. So I need an angle first. So what I'm going to do is I'm going to draw myself a line from P to what? N. If I do N on here, what else do I have to do? N on the other one. Then you just have to measure it. What'd you guys get? I think it was something around 40. Okay, does that look like a 110-degree angle, though?
No.
No. Right? You have to use a protractor. Here's a protractor. Spin it around. Put it in the middle. And start at 0, right? So here's 0, 10, 20, 30, 40, 50, 60, 70. How'd you get 110? Ah, look at that. You got to think about it. You didn't start at 0, you started at 180. Now that's exactly what I'm talking about, Michael. Did you just figure out how you made that mistake? Are you going to make that mistake again? No, you don't start at 180 and count backwards. You start at 0 and count forward, right? Okay, good job. That's exactly what we need to do. So angle of rotation is around 70. Which direction did I go? Which direction is if I go from here to here? Clockwise. Okay, use the figure to the right. How many lines of symmetry does it have? A lot? Okay, let's start counting them. So the obvious ones are these, right? 1, 2, 3. Any more? Straight in half. That's the easiest way to see if there's more, right? 4, 5, 6. As soon as you see, guys, as soon as you see that there's one right down the middle, you should check in between the other petals too. You know what I mean? So that's 6. Does the figure have rotational symmetry?
Yes.
Yeah, it does? What could you use to check?
I use
Yep. Use patty paper. If you use patty paper, you should be able to see if when you turn it, oh no, can't see it because it's not, I would have had to like trace it to be able to do it. So I'll do it on the side. So can I turn it and it still looks the same? Yes. So it does have rotational symmetry now. I just got to figure out how much of a rotation.
The small thing.
How could I figure it out with math?
3 and no, 6 and 360.
Yeah. There's one. What do we call these again?
Line sequences.
No. Michael, they're vertices. So how many vertices do I have? Well, not really. It's not vertexes. Because vertex is singular. Vertices is the plural form of vertex. So it has 6 vertices, therefore 360 divided by 6. Right? Which is 60. Because you put rotational, you probably got partial credit. Okay, let's switch over to B. Is it? Well, okay, so let's do this one now. All right. Use the graph at the right. Name the sequence of transformation that can be used to map MNP to M prime, N prime, P prime to show they're congruent. So what would you use? Patty paper. And I would take this and trace it, horrible tracing, and I would see, what do I have to do to get over there? Let's see, can I just go like this and down? Can I translate? No, that's not going to work. You think we could reflect? Let's see, the only problem is you got to think of it, let me redo this. Okay. What did I just do? Did you guys realize what I just did? I traced the wrong one. Why? Why did I trace the wrong one? How do I know I traced the wrong one? Yep, I traced it. I know is because when I went to go copy my letters, I had primes here. That's the way to say, oh, I just made a mistake. Make sure you write your letters, because if I have my letters, I can see exactly what's going on. Because if I try and rotate this, I can see where the M and the N and the P are, right? So, to get from here to here, you guys said you want to reflect it. So let's reflect it across the X, which would be our reflection this way, right? So that would be over the X. I don't think I need to do any more than that. Look. That's N and N, upside down though. And that's M and M down here. You guys see that? I want to make sure you guys see that. You told me to reflect it over X. Do you have to? What happens if I reflect over Y now? It's not. Let's try it. If I reflect over Y now, looks like that. So I needed to only reflect over X and then translate. You would write, let's see, name the sequence of transformations sequence mapped to show they are congruent. So reflection over X, and translate. What is the coordinate rule for the transformation? Oh, so all you have to do is just say reflection and translation. And then on this one, I want the actual rule. So what is the rule to reflect over X? No. The rule. If I want to flip over the X, does the X change? Look at M is here. The only thing that changes is Y. Do you see that? It's changing. When I'm going over X, the only thing I'm changing is my rise. Does that make sense? Michael, do you see what I'm saying? When I go this way, what's changing? Not the X. Look, the X is right here. I'm not moving on the X, I'm moving on the Y. You see that? And when I go this direction, am I moving on the Y?
No.
It's reversed. Do you see that? If I want to go over here, right, over here, I'm going to go on the X highway to get there. If I want to go this way, I'm going to go on the Y highway. All right, so the rule would be what? Which one changes, X or Y? So it would be opposite of Y. And if you can't figure that out, if conceptually that doesn't make sense to you, give me coordinates. 1, -2. What happened when I went over? Where am I at now? 1, +2? Michael, you see this? 1, +2? So when I reflected, what happened? Did 1 change? So X stays the same. Did Y change? It became opposite. You see how I checked that? Kevin, you see it? How I checked it? Yes.
Do we have to write the transformation for the translation?
Yes. So that would be, the translation is what happens? How far do we have to move on the X? Let's count. 1, 2, 3, 4, 5, 6. So how would I write that as a rule?
X, Y, and then translate the X, and then Y -6.
X -6.
Oh, I-
Y doesn't move. We're going on the X highway, right?
Oh, yeah.
Make sense? Okay. If you want, you can go home and try this stuff and see if you get it right, right? And then come back, and if you still don't get how to get it right, we can look at it again, okay? All right, reflect PQR across Y. So first thing I'm going to do is go across Y. When I go across the Y, what changes? I'm going over Y, what changes? The X. When I go over Y, X changes. If you don't know that, count. How far am I going to go over for P? So I'm going to go 2 more. Good. How far am I going to go over for Q? 4, so 4 more. Q prime. And how far for R? 4, so 4 again. Then, what happens? Now, see, this is where I should have just made it prettier, because I'm going to move it, right? So I take that. 1, 2, 3, 1, 2, 3, 4. What's this called? That's the vector. In what form? Component form. I'm just trying to get that vocabulary back and forth to you, okay? That's the vector. That's what tells you how you need to move, right? All right, draw the image of ABC after the following sequences. All right, so this one is a little different, right? What's happening to this figure when I multiply by 2? It's getting 2 times larger. So whenever you have something like that, guys, instead of trying to do it visually, you should probably just find your points and do it mathematically. Good. So A, B, and C. So what's A?
Original A, 2 and 1.
2, 1.
0, 2 for B.
0, 2 for B.
3 is
4, 3. So if I want to get A prime, B prime, C prime, what would that be?
4, 2 for A.
Wait, hold on. So what am I going to do to my 2?
Time equals
Time, because that's what it tells me to do, right? Multiply them both by 2. Devin, you see that? So this is going to be 4, and this is going to be 2. 0 and 4. 0 times 2 is 0. 2 times 2 is 4. 4 times 2 is 8. And 3 times 8 is... I'm sorry, 3 times 2 is 6. Got it.
So you just right now,
The vertices.
the vertices, then you multiply by 2.
Yep.
That's what I'm saying.
That's what it's telling, the rule is telling me to do. Now what do I need to do? What's this say? No, hold on. Devin,
Minus 3
And-
y makes 26.
so what am I going to do to all my x's right here?
Subtract by 3.
And what am I going to do to all my y's?
Subtract by 6.
Yes. Make sense? It tells you exactly what to do, right? So here, that's going to be A double prime, B double prime, C double prime. So what would my A be? This is trickier, right? What's 4 minus 3? And what's 2 minus 6? Yep, negative 4. What about 0? 0 minus 3? And 4 minus 6? Negative 2. And 8 minus 3? And 6 minus 6? That's my final point. 0, negative 4, negative 3, negative 2, 5, 0. There it is there. Does it make sense? Looking at that picture? So it's gotten bigger, and then it shifted down 6 and over 3.
It should be positive 1. You put it at negative 1 comes 1. Or negative 1 common negative 1.
Tell me your off 1, negative 4. Okay, 1, negative 4. Thank you. And negative 3, negative 2. Hey, it looks good to me.
I get the point.
You got it? Yeah?
I thought that was fine too.
That's okay. Anybody want me to continue? Yes?
Number 16, 17.
Yes. Okay, so
Yeah, the 16 is fine.
on B or A?
Okay.
Which
Oh, on B.
which test do you have?
B.
B. Okay. You too, Devin?
Yes.
You have B? Okay, good. So we're going to do 16 and 17. Have a good weekend, guys. Uh-oh. New page. All right. So 16 is reflect triangle ABC over the y-axis. Okay, let's do that first. Over the y. What happens when I go over the y? What happens?
The X change.
The x changes. I just want to keep asking you guys that, right? You don't necessarily have to do it that way, but I'm going to keep asking. So how could I go over the y-axis just by counting? Over 2, 1, 2, and then 2 more. 1, 2, there's A prime. 1, 2, 3, 4. 1, 2, 3, 4. There's C prime. 1, 2, 1, 2. Devin, are you getting this? Is this part okay with you? Yeah, you got it? What about you, Leilani? You get the whole going over? Okay, just want to make sure. Girls, yeah, we're good with that part?
Yeah.
You did good on this one?
Yeah.
Okay. So that's going over the y. Now what does it want me to do?
Go to the,
Not yet.
times rotating by 2 and then
What do we call this? It's the vector, right? The translation vector. So how much am I going to move? Over 2 and down 1. Over 2, down 1. So each one of these is going to go to the right 2 and down on the y1. Over 2, down 1. There's a double prime. Over 2, down 1. There's C, double prime. And over 2, down 1. There's C. Did I do that right? Yeah. Double prime. Yes. Are you 6?
Huh? You serious?
6 or 5?
5.
There you go. Okay. That was floppy. Now what? Rotate it 180. 180 is on the opposite, right? Or you could pick it up and rotate it 180 with patty paper, right? Patty paper would be the easiest, but I don't want to confuse you guys with the patty paper that I use here. I wish I could figure out how to make it rotate from the center in this, like somehow connect it here, you know what I'm saying? That would be really, really nice. Okay, so if I were to rotate this guy so that this is now on the opposite side of the graph, I'm going from the center, right? So if I have to go this far to get to the center, hold on, record. So go up 3 over 2, up 3 over 2.
Wait, but why would you go up 3 over 2?
I don't know.
Because I want to go across 180 degrees, directly across. So how do I get here? I can't just walk there. I have to take street. Right? So if I stay on the lines, I go up, or I could go up 1 over 2. That doesn't do it, right? To get there, I got to go up 1, 2, 3, and over 2. Up 1, 2, 3, and over 2. So what am I going to do with A? How do I get to 0? Up 2, so I should go up 2 more. And B?
Over 2, up 3.
No, I'm going to 0.
Okay.
See that? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's complicated this way. You guys should just use patty paper.
I do. Not that way.
Right? That would be rotated 180. 17? Phi. So ABC is congruent with DEF. You guys, phi. You should use color. So A goes with what?
A goes to D.
D.
Oh, D? Yeah.
See A and D. And B goes with what?
E. And C and F.
B goes with E. Wouldn't it be easier if you used some colored pencils
Yeah, that's fine.
or some highlighters on a test? And C and F?
I didn't use it at all.
C and F. That gives me an idea of what's going on, right? So now it says, what's the length of AB? Where's AB? Right here.
Yeah.
Well, where's its counterpart?
C, D,
DE, right there. So if this is equal to this, what can I write?
3x.
See, this equals that. If they're the same, they're equal. What about the measure of EDF? Where's EDF? Let's see. EDF. So which is the angle? No, not on here. EDF. Hold on, you guys don't understand what I'm saying. You know how it says EDF? Which one of these letters is the vertex?
No, that's,
No, it's the middle one. It's always the middle one. See how I'm saying EDF? It's this one right here. So if it's D, which one is its corresponding angle? Here's D. A. That's this one. They gave us an angle in here. If A is congruent with D, then its measure is the same or equal. So I would just say 5y plus 20 equals,
so, this is the answer for 70?
no, you have to solve for x. Subtract 3x from both sides, right? You guys know how to do that.
Yeah.
You're having a hard time matching stuff up and getting there, right? Does that make more sense?
Yeah.
I need color pencils.
You need color pencils. Right all over your test.
Yes.
So B is just asking me if you have to solve it.
What is it? It's asking for the measure. It's this right here, the measure. It says the measure. That's what that M is. Okay, are you guys done? We can do more next week?
Yeah.
Okay, fantastic, good